Okay, this is a explanation of smart pointers in C++. So, smart pointers are essentially a wrapper around raw pointers, and they solve a number of problems that raw pointers have. Let me explain those problems. When you're creating raw pointers, and those are things like these, int star pointer equals address, car, star pointer equals address, foo star pointers equals new foo. So with all of these, we're just creating the type and setting it to an address. And the thing is, like about objects here, we're gonna have to delete this manually. We manually said new foo, and we're gonna have to delete it later. The thing is, if you forget to delete that, then there's memory leak. If you um, if you delete that but you delete it again, we have a double free error. And if you delete this object but the pointer remains or a different pointer was pointing to it, then those are dangling pointers. And those are all bad. So, it's not to say that you should never do this, but the rule of thumb that I've found is that they say you should use raw pointers if it's not an object, if there's no like ownership relationships, but if there are ownership relationships, for example, mostly in object-oriented programming, then you should use smart pointers. So yeah, a smart pointer wraps around raw pointers, and it handles the creating new object. It handles the freeing of the object within itself. This is an application of resource acquisition is initialization, RAII, which essentially means that everything deals with its own mess by self-destructing itself. I had the misconception that it would self-destruct itself and everything else that it owns, but that's actually not part of this pointer. It's part of the destructor, and that's up to whoever implemented that. But yeah, whenever a smart pointer is out of scope, it cleans itself up and everything it owns. So, oh wait, what is this referring to? Yeah, I thought when we were talking about something getting out of scope, I thought it was the object getting out of scope, but it's actually the smart pointer that gets out of scope that activates the deletion. Uh, I like to use the analogy that this kind of smart pointer rule that it cleans itself up after it's done is like kind of like the natural law of death in real life. Like otherwise, everyone lives forever if death isn't real. But yeah, beside that, here are the three types of smart pointers, and I'm gonna write out how you call them as well. Let me turn into the code fonts. So std unique pointer entity. This would be your class. So we have this as well, which handles exceptions. Because technically you could also just do entity, new entity, and you put that here without the equal sign. You can't use the equal sign, by the way. But this is how you make it. And essentially, this is like the simplest smart pointer. The pointer itself is stack allocated. So when that pointer dies, then it deletes the corresponding memory at the pointers. And it's unique. What does that mean? Well, when you make one of these, you essentially bind it to the memory that it's pointing to. So you can't copy it, you can't pass it as a reference, You can't store it in another class. You can't pass into a function. Because this is the only thing that can delete this. We don't want anybody else to be able to delete this. And this is useful in like object-oriented programming if you have, for example, you have like, I don't know, you have a person and you have their special item only they possess. So like, okay, I can't think of any examples, but if they have this item, we don't want like someone else to point to that item and delete it. We want only that person to be able to delete this item, so it would be good to use a unique pointer in that case. Now, what if you wanted to have other things point to your pointer, sorry, your memory? For example, what if we have a graph of nodes, and we want them to point to each other? Well, that's when you use a shared pointer. It's written as this: std shared pointer entity shared entity equals make shared. And you can only do this one. You can't like do the other version where it's entity, like new entity, stuff like that. You can't do that. And what makes this one different is that you can copy it. You can share between objects. And this helps, like if you have this item and other items are pointing to it, then it'll only delete after there's no more items pointing to it. Like this. And the way that it does that is it has a reference count. This is the main difference between the shared pointer and the unique pointer. It has a reference count. So if we had these back again, the reference count is 3. And I think it's really smart. Like with the raw pointers, you don't know if you're forgetting something, if you forgot to if you forgot that you were referencing referencing an object earlier, and then you free it, that other pointer becomes a dangling pointer. But in this case, that will never happen because we keep a reference count and we only delete after nothing else points to it. But there's other things that can happen. Like what if you had 2 shared pointers pointing to each other? Then for whatever reason, I saw an example where it's like, oh, these are always going to keep each other's reference count non-zero, so they'll never delete, something like that. Or if somehow this dies, like for some reason, I don't really remember, it's bad because one of them will be left over with a reference count of non-zero, but it can't do anything. But what you can do is you can create a weak pointer. A weak pointer, I nested it here because it's related to the shared pointer. It essentially allows you to point to stuff, but you're not increasing the reference count. Let's say this is the weak one. Yeah, that's the weak pointer. So you initialize it like that. And weak pointer syntax. Yeah. So I think this is where the name is. Weak entity. So yeah, that's everything I just learned about smart pointers. I'm gonna add corrections in the comments, and yeah, that's it.